This class will cover the basics of wireless systems and network basics for those wireless systems when it comes to computers. We'll be talking about Bluetooth as well as satellite technologies, but the most common is what we refer to as Wi-Fi, or 802.11. First, we'll be talking about wireless and 802.11, which is a lot for people refer to as Wi-Fi. It's the most common one out there and one that you will run into the most in your endeavors in forensics and cybersecurity. A wireless LAN or WLAN is nothing more than wireless networking cards that are hooked up to a network and eventually is hooked into the wired system of a business or the internet. There is a need of an access point or bridge that will bridge the wireless network itself onto a wired system or the LAN in general, although it's not required. 99% of the systems that you'll run across will have an access point. Here's a diagram that basically shows a typical office architecture where you have a wired network, not Ethernet, and then you have an access point plugged into that Ethernet network, and from there, through the wireless system, it is connecting with other workstations. So basically, the wireless just replaces the wires that are running to workstations on a network. So quickly, let's go over some terms. You'll have an AP or access point. The most common is what you see in the bottom left-hand corner of the screen right now, the link sys. That is probably in about 60% of all the homes and businesses out there. And an access point can also be what they call a router access point. It acts like a router or switch. As you can see on the graphic on the right-hand side, there'll be an Ethernet port that you connect up to the internet. Let's say in a home environment, a cable modem. In a business environment, that is connected to the main business network. It may have LAN ports in the back. Most of the routers do come with at least 5 connections for LAN ports. This one has 4. And that's for wired systems. And inside the access point will also be a encryption, which will be like WEEP. That's an encryption type, but we'll have another slide on all the encryption types. What you need to know is that access point not only can have wired systems plugged into it, but it also is a point at which it can route data packets as they go through the wireless network to other areas, such as you have a camera hooked up on the wireless access point. You may be routing a port from the outside of the internet to a specific camera. Or let's say take the case of a sling box for TV and you want to watch your TV remotely when you're at an airport. You are actually routing at the Linksys router a specific port to that IP that is assigned to the Linksys box. And when you're out in the field, as your cell phone connects up to your IP at your home, it will be routed through that router and then onto the sling box, and you're watching TV on your TV set remotely. A wireless access point can also be set up in what they call an ad hoc mode, or it can be in an infrastructure mode. What is an ad hoc mode? It is a peer-to-peer mode, normally not connected to a WAN or the internet. In other words, you can actually take the access point, set it up, not have it connected to the internet or the wired network of the business. Yet everybody on that wireless network can talk and share amongst themselves. It's just that they're not connected to a larger LAN or a outside internet access point. Infrastructure mode connects all the wireless workstations on the wireless LAN to a wired LAN or the internet. That is probably 90% of what you'll see out in the field. Normally 802 is used and wireless systems are used because laptops and iPhone touches and iPhones and cell phones can use that Wi-Fi connection as they walk around to make not only phone calls, but they can connect into the local network. So you're probably saying, with all that, why do they do that when the wireless speed on a wired system is so fast? Well, here are some of the wireless speeds that you'll see out in the field. The most common one you see in a residential area would be the 802.11a and G, although N and AC are coming up because of the advent of video streaming. 802.11 was the original wireless network, which is just 2 megabits. But then again, we're talking about, this is like 1985, 1987, back when even 2 megabits was faster than most of the internet connections to the home, which were at 54 kilobits. The fastest one today that is in service is the 802.11ay standard, which is 100 gigabits. And that is slowly making its way into homes now. The routers are about 5 times more expensive than you would if you bought an 802.11g or an 802.11ac, but it's also 3 times faster. Let's talk a little bit about how the 802 wireless system is set up and also how it may be set up in a business environment. First of all, the standard defines a total of 14 different frequency channels. So you have 14 different paths for data. Or in any situation, you could have up to 14, well, in the US, only 11, access points on different channels so they wouldn't interfere with each other. Now, the 14 that's actually allocated, like I just said, in the US, we're only allowed to use up to 11 of them, although Europe can use 13 of the channels, and in Japan, they're only allowed one choice, and that's channel 14. A channel represents a frequency or center of a frequency, and there are 5 megahertz of separation between the center frequencies of each channel. As you set up an access point, you'll notice that it asks you for the frequency or the channel that you want to operate on. And here's why. Let's say in a business environment, we'd have 3 different access points because they were separated by at least a 300-foot difference. And we wanted to have wireless access for our employees as they walked around the building. Well, you couldn't have all 3 access points on the same frequency. It would be interfering with each other. So this is why they have the different frequencies. You'd set one, let's say at channel 1, another one as channel 2, and another one as channel 3. That way, as you went, the channels would not interfere with each other, the access points. And also you could set your computer up so that as you walked and the signal got really weak on channel 1 and channel 2 got stronger, it would automatically switch across to channel 2. That sounds a little bit like the cell phone technology that we learned earlier, isn't it? It's almost the same, except in this scenario, there isn't a main center that is controlling the computers. It is the computers themselves that are saying, hey, this is one is stronger, I'll just switch to that channel. Here's an example of up to 8 different channels and how they stack up to each other so that they won't interfere. Theoretically, you could actually put channel 1 once again down at the bottom of the stack in between 5 and 6. And it would not interfere with the people on the channel 1 at the top of the stack. That's a little bit more like cell phone usage in the hexagon shape. You need to know this because as you go around and pick up computers and you need to find out where a computer was talking to what access point, the channel it's on is part of the log. So now you could actually retrace the steps of an individual as they walked around a business from access point to access point. So what does a PC need to get onto a wireless network? Well, it needs a NIC wireless card to communicate with the access point. Most laptops and cellular phones and tablets already have them built into the device itself. However, sometimes they do not, so you would have to purchase one. The one on the left is a typical card that is used inside a personal computer, a desktop type situation. Same with the center one, although that one is made for a situation in which you have weaker signals for it has an outside antenna hooked up to it. And then the one on the left is a USB wireless card. That is mainly used on laptops that do not have a built-in wireless card, or you want to hook up a specialized antenna to track down and trace where a wireless access point is physically located at. That type of USB card is what you'd be getting so that you can hook up a different antenna to it than the one that is supplied. But more on that later. Let's quickly talk about Bluetooth. It's just a different version of wireless, and it's made for very short ranges, 60 feet max. Normally it's about 30 feet. But it's also used in not only cell phones, but we're starting to see it used widely because of its short distance in things like cars, walk-around phones for the home, keyboards, mice, an earpiece to talk on the telephone or to talk through Skype. Bluetooth is, even because it's on cell phones, being used like in motel rooms or hotel rooms. As you walk up, the door will connect to your Bluetooth device inside your cell phone. It will acknowledge each other through an encryption means. And then you have the application running that says, hey, I'm here at the Hilton and I've been assigned room 1013. Room door 1013 will now open for you because you're sitting within a foot of the door. That's the power of Bluetooth, and we'll see more of that coming in the future. You see it currently in cars, where you can get into a car and your center console has the radio and a GPS map going. And if you have a earpiece in your ear that's Bluetooth, it will connect or pair with the Bluetooth inside your radio of your car. At the same time, it will Bluetooth into the cell phone of your car. And as you're driving down the road, a cell phone call comes in or a text message comes in. It's transmitted to through the Bluetooth to the car screen. You could actually read the text on the screen instead of having to pick up your cell phone and try to read a text as you run into the car in front of you. As we were just speaking of Bluetooth, one of the reasons why you're learning about that also is because imagine you walking down the street. Every car you pass that has the modern radios in them will have Bluetooth active, and it's constantly active even if the ignition is not turned on. It is still trying to pair with each of those cars as you walk down the street. So there'll be a log actually in that vehicle of your headset or your phone trying to pair with the car. That can be important in a crime scene where you're trying to figure out which way the bad guy left. But let's say you're trying to locate a Bluetooth device, or you know that a suspect in a great distance is actually transmitting on either wireless 802.11 or is using Bluetooth. How can you pick up those signals or find that access point in a building? Well, here are some wired antennas that are directional antennas for both wireless and Bluetooth. The antenna on the top left is about a $20 item that you can buy off the internet. And that is used most widely in the law enforcement realm, being hooked up to a NIC card on a laptop and using a application such as NetStumbler to see the signal strength of the access point. And as you walk around, you turn the antenna around, and at some point the signal will be the strongest because you're pointing the antenna directly at the access point. And that's how you'd follow yourself to an access point. The one on the bottom left was used to transmit and receive a Bluetooth signal almost 17 miles. So the same thing can happen with both Bluetooth as well as the normal 802.11. A good example of that also is somebody's trying to get internet in some place that they don't have a satellite receiver or pay for a satellite receiver. They can actually have somebody set up a similar type of antenna up to 26 miles away, and they can exchange and hook that up to an access point, and now you're sharing through a wireless connection a long distance internet. Of course, with the advent that hackers to begin with, but that we're using the wireless, anybody can pick up a wireless signal if they have an antenna and a wireless card. So now we have to hone it down a little bit and say, okay, well, we want just not anybody connecting up to my wireless system. I need it encrypted so that somebody, number one, can't see what's being done on my wireless network, and then number two, I restrict access to somebody. So that's where they came up with the encryption standards such as WEEP, WPA, or WPA2. As you see on the right-hand side, there is a typical environment, let's say in a home or a workplace, where you'll have wireless media players, an entertainment system, a work PC, a laptop, a PDA or wireless phone, a camera out in the field. All that would be connected up to your access point and then through a modem out to the internet. But you'd want to protect that wireless access point so that no one can, number one, use it or get into those other devices on the network, but also, number two, not use your wireless internet connection to, let's say, send spam or something like that. So one of the first things you do in a wireless internet or a wireless investigation is, was there encryption installed? What type? And how strong was it? What was the password? So what are some of the encryption standards for wireless? Well, we have the WEAP, which is Wired Equivalent Privacy. That is now easy to break. In fact, they make applications that it can listen in on a WEAP channel and in less than 5 minutes tell you what the WEAP key is. So that's really not a great one to use. Wi-Fi protected access came out because WEAP got broken, and that's a lot stronger. But even beyond that, we have Wi-Fi protected access with AES, or the Advanced Encryption Standards, WPA2. That is a very strong standard, and to this date has not been broken. Most access points that are sold to the public and businesses provide all those as a encryption means on the wireless system, or no encryption at all. Just for the shins and grins, sometimes go down the street in your car and leave your computer on, your laptop on, and searching out access points. You'll be surprised at how many you will find that have no encryption installed at all, so that anybody can get onto the access point and use the system. An example of that is like Starbucks. Of course, they do it to be convenient for their customers. But the same thing can happen in a neighborhood. Someone can come down a neighborhood and see that someone has a Wi-Fi connected. They have no encryption on it, so they connect onto it and start spending spam, or worse yet, start doing criminal activity, and all the activity will come back to that home and that connection on the internet. In this lecture, you've now learned about Wi-Fi in general as well as Bluetooth, and how the system works and what you may be looking for. This class will be very important in the next classes or lectures in class 3 and 4. Stop and think for a second that when you're investigating a crime, how many places Wi-Fi can actually be at. You can have Wi-Fi in cars via Bluetooth and Wi-Fi connections, as well as a train accident or an airplane accident. Imagine the Wi-Fi on an airplane. What could happen, and would you have the ability, and would it be a part of a evidence trail in a crime or not? You have wireless cameras around the homes and businesses. You have access points, and those access points would have SSIDs, which is a unique name given to any access point which identifies that access point. Now granted, the SSID is put in by the user, but they're normally unique so that two access points will be in the same area at the same time. Think about home automation. All the home automation devices on the market today use Wi-Fi. Think about encryption. Okay, is there encryption? Is there not? If there wasn't encryption, did a hacker actually access an access point for someone's home or business, in that the real suspect is not actually in the business or the home, but somebody on the outside? Same thing with vehicles. The vehicle, accessing the Wi-Fi in the vehicle. Those vehicles that have Wi-Fi and internet capability, was it the owner? Was it someone else? What about drones? All drones today are accessed via a wireless, normally an 802.11. Some by cell phone, but mainly 802.11. That is a source of information that may help or not help in a case, but it still can be a piece of evidence that can give you facts. That's why Wi-Fi is important for you to learn and to study more on in the coming months if you're going to go into the cyber forensic field and the cyber investigation field. But later on that, in class 3 and 4, as we give you logs and train you more about where to find those logs and those sources of information and evidence. Now let's go on to our next class.